Okay, 12b, we're converting a rectangular equation into polar. So 12 is only going to go from rectangular to polar. Formulas that you would need for this are some conversion formulas, and I'm going to go ahead and write those down. So these are the ones that you'll need to know and have on your note card. Are these three formulas here? That's the ones we use from going back and forth. Okay, so first thing we want to do, we could go ahead and substitute in right away, but I see some things that I can do here first. So before I start and just throw things in there right away, the first step which would be better is to see if I can simplify that a little bit more. So I'm going to expand x minus 2, and so x minus 2 is the same thing as x minus 2 times x minus 2. So we don't want to just distribute the square to each of those separately. We have to multiply it out, do FOIL on that, distribute it. So if we take x squared minus x minus 2 times x minus 2, you're going to get x squared minus 4x plus 4 plus y squared equals 4. So we're going to get that as the next step. So the first thing we do is multiply that out. Don't forget about the middle term that you'll get here. And by doing that, we notice already that the 4's can cancel out from both sides, which is nice. Now, if I look at my list of identities that I have here, I see an identity here with x squared and y squared. So I'm going to rewrite this and put the x squared and the y squared together, and we're allowed to do that, just moving those around. Because the 4's cancel out, we don't have anything left on the right hand side anymore, so it's 0. So now that I have this, x squared plus y squared, I can put in a r squared, and then instead of the x that I have there, I'm going to replace the x with r cosine. So this is actually where the step that occurs where I'm plugging that in. So if I would have done that up here, that would have made that problem a lot more complicated. So that's why I wanted to work with x's and y's first to multiply it out and simplify as much as possible before I take these and put them in. So now I have something that looks a little bit, things canceled out, and it was a lot easier to make that substitution. So next thing I need to do, whenever I set anything equal to 0, I always want to factor it. I look for a common factor, and I can pull out an r from this. So I'll pull an r out, and I get 1r minus 4 cosine theta. Okay, so again, if I multiply this, I get r squared minus 4r cosine, so I did that correctly. Whenever you factor something, always want to multiply it back through just to make sure you did that part correctly. Now, once it's factored, we're going to take both of them and set them equal to 0. So I get r equals 0 and r minus 4 cosine theta equals 0. Now, if you imagine what r equals 0 is, r equals 0 represents a circle with a radius of 0. Now, you can't have a circle radius of 0. That doesn't actually end up being one of our solutions. So we're going to cross that one out. But this one we can continue with a little bit more. We can solve for r, and we get r equals 4 cosine theta just by moving that term over. And this is what you actually want to put for your answer. And this would allow us to go back the other way. If we multiply both sides by 4 and work backwards, we would be able to eventually get back up to this step here. So it is actually equivalent. Okay, so this is what I would put down for my answer. This whole expression converted into polar would look like this. Remember that if it asks you to convert something into polar, you should not have any x's or y's left in your answer. You should only have r's and thetas.